Hello everyone, in this video we'll be solving problem 198 house robber. The problem statement is we are given an integer array nums representing the amount of money in each house. We need to return the maximum amount of money we can rob tonight without alerting the police. The police will be alerted automatically if we are robbing two adjacent houses due to the security system in place. If we look at example number 1, the amount of money we have in each of the houses are 1, 2, 3 and 1. To rob the maximum amount without alerting the police, we need to rob the first house and then the third house, which will give us the total of 4. After robbing the first house, we cannot immediately rob the second house or else the police will be alerted. And the same logic is valid if we rob the second home and then try to rob the third home. I hope you are able to understand the problem statement. Now let's switch to whiteboard and discuss how we can solve this problem effectively. The simplest way to solve this problem is to use brute force, where we'll try to identify all possible combinations to see what is going to be the maximum results. For instance, we can start the robbery from the first home, record the total we collected, and then move on to the next one. As we need to skip at least one home, we won't be able to rob 6 along with 2, so we need to skip that and go to house 3, that is index 2. We'll add the amount available at the house and then continue traversing. This will continue until the end, where we will record the maximum amount we were able to rob if we started from the first house. In other words, we are trying to build a decision tree which will help us identify the maximum amount we can rob across all of the houses without alerting the police. The decision tree would look something like this if we start with the first home. And as we go deeper, there will be more decisions at each level. The idea is to traverse through the decision tree, record the total amount we can rob, and compare it with the max amount to make sure it is the highest. As we are trying to calculate the maximum amount we can rob, the decision tree should only start with the first two elements. We cannot skip those or else the amount will not be correct. If we start a decision tree from the third element onwards, the first two elements will not be included, which will skew our output. Even though this solution is simple, the time complexity is going to be high. As we are running nested iterations, in the worst case scenario, the time complexity is going to be O of n square, where n is the number of elements in the input array, and the space complexity is going to be O of 1, as we are only using this one variable maximum amount to record the maximum amount we can rob. Now this is one way of solving the problem where we are using the brute force and the greedy approach. Now let's think about how we can improve this solution using memoization. Instead of starting to solve the entire problem in one go, let's break it down into smaller subproblems. To explain the solution better, I'll use a smaller example with 3 elements in it. Let's start by focusing on calculating the maximum amount at n position. As we can't rob adjacent houses, the total amount we can rob is going to be the value at n with n minus 2. And to get the maximum value, we should compare the sum of the two numbers with n minus 1. As it is possible that the amount at n minus 1 home could be greater than the sum of n and n minus 2. This is how we can represent this logic mathematically. Max between the sum of amount at n minus 2 and n and comparing it with amount at n minus 1. Using this formula, we can easily determine the maximum amount we can rob across 3 homes. Using this logic, we can easily determine the maximum amount we can rob at each home and build on top of it as we traverse through the input array. Let's do a couple of dry runs to apply this formula to the input in front of us to understand it better. For the first 2 homes, there is no way we can apply the formula, so the maximum amount will be the amount available in each of these homes. So we'll save that as is to the dynamic programming array. With I is equals to 2, we are at a home with value 1 and applying the formula n minus 2 is 2 plus amount of n which is 1, the total is 3 and comparing it with n minus 1 which is 6. As 6 is higher, we'll save it in the dynamic programming array. In other words, if we had only 3 houses in the input array, the maximum amount we will be able to rob at the third element, that is house 1, will be 6. Moving on to the next element with I is equal to 3, the value is 7 Now we'll apply the same formula where max of amount of n minus 2, which is 6, and adding it to the current element, which is 7, the total is 13, and it will be compared against 6. As 13 is higher, it will be saved in the DP array. Next value in the array is 5. Applying the same formula, this time we are adding 5 with 6, which is n minus 2. The total is 11, and we are comparing it against 13. So 13 will be saved at that position. Next element is 1, repeating the same process, comparing 1 plus 13 against 13, which is n minus 1. The total is 14, which is greater, so we'll save 14 in that position. Last but not the least, when value is 3, adding it with 13, that is n minus 2, the total is 16, which is greater than n minus 1. So we'll save 16 in the last position. Once the iteration is done, we will return the last value that is saved in the dynamic programming array as our output. With this solution, our time complexity is O of n, as we are only running the iteration once across the input array, while the space complexity is O of n because we are maintaining this dynamic programming array to record the maximum amount we were able to rob at each house. As we are only using the amount we robbed at n-1 and n-2 position, instead of saving the entire dynamic programming array, we can optimize it to only use two variables to record the values. This will further improve our space complexity to O of 1, that is constant space. I hope you were able to understand the explanation. Let me show you how we can implement this solution using Java. Here's the solution in Java. In the main method, I've initialized two variables, previous and current, which will hold the maximum amount that we were able to rob at n-1 and n position. After that, I'm starting a for loop to iterate through all of the elements in the input array. Inside the for loop, I'm calculating the maximum amount we can rob at the current position by comparing the current from the previous run and adding the n-2 value with the current value that I is pointing at. And whichever is higher is going to be saved back into the current variable. After the for loop is complete, we'll return current as our output, as it will hold the maximum amount we can rob at the nth position. This code, when submitted on LeetCode, beats 100% of the submissions in terms of runtime and 47% in terms of memory. Thank you for watching this video. I hope you were able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.